everyone, Cody here. So I'm at my property in Nevada, and on the property is a dry stream channel which only occasionally has water. Like when we have a big storm and it floods, the water will run down this spot right here. Now, at the very bottom of the channel you can see there's a dark streak, and that's what today's video is going to be about. So this dark streak is iron 2,3 oxide, otherwise known as magnetite. And it's heavier than the other minerals in the area, so it collects right at the very bottom of the stream channel. It weathers out of the rocks in the area. So this is a volcanic rock. It's very high in iron. In fact, you can see a magnet sticks to the rock. But the magnetite particles that come out of the rock are what's magnetic. You can see I can pick them up with a magnet pretty easily. In fact, if I wanted a bunch of this stuff, which I do because it's a great oxidizer for thermite, I could just come over here and run a magnet along the ground and pick it up. But this is very time consuming, especially because it picks up a lot of dirt along with the magnetite. So I have to take it off the magnet, spread it out and pick it back up to purify it multiple times. And, well, that's what I started doing, but over time I've become much better at it, and today's video is going to be showing you the process of getting as much of this material as fast as possible, at least what I've come up with so far. I find that the fastest and easiest way to get the iron is just use a shovel and scrape the dark streak up, put it in a bucket, just like that. Now, of course, I do get a lot of dirt doing it this way, but a magnet wouldn't get the iron that's buried. See this dark streak that's down here? That's from a previous storm. Now that I've picked up some more, I'm going to take it back to base for processing. So here we are at base. There's the processing plant. I'm going to push the ore off onto the ground next to it. To be processed, the material has to be completely dry. And as you can see, this material that I've just dug up is a little bit damp. So I'm kind of throwing it over a wide area to spread it out so it dries faster. Okay, so I've got everything turned on. I got the material spread out so it'll dry quickly, and some over here on the side that's already pretty dry. So I'm going to start with this material and start processing it. First step is to run it through this screen. The sand and gravel that I produce as a byproduct, I'm just going to be putting on the ground here. I wanted to put gravel down anyway because of the clay. When it gets wet, it's super muddy. So the screen, of course, gets rid of large rocks that would plug up the system. And there's a fan going, blowing through here, and that's to remove grass and other organic fibrous material that would fit through the screen but still plug up the system. Now that the material is screened and most of the grass blown out, I'm going to start shoveling it into this bucket so that I can transport it to feed it to the system. And there we are. It's being processed. See, the material is flowing down and out this hole, much like the sand does from an hourglass. It is landing on this big ball of iron here, which is stuck to a large neodymium magnet. Now most of the sand just hits this and bounces off, and it kind of fans out and lands over here. But some of the sand is magnetic and is attracted to the magnet, and instead of bouncing off, it kind of gets stuck and it forms these little spires, which you can see slowly moving down and eventually getting to the bottom of the magnet here. The magnetic field's weak enough that they just kind of fall off. See that? They're landing over here in this bucket. The dirt and rocks are landing here, and the magnetic magnetite is landing over there. Now you might notice I've got a second one over here. Same thing, except this one's using a smaller magnet. And I find it works just as well, but you can't feed it as fast. So the hole that the sand comes through has to be a little bit smaller, and as a result, you need to pass the material through a finer screen so that it'll come out that smaller hole. See? There it is. See, we're getting about the same amount of separation between the two of them. I think that looks kind of cool. This version of the apparatus using the large magnet is able to process a 5-gallon bucket's worth of material every 8 minutes. The smaller version, using the smaller magnet, it's able to process the same amount in about half an hour. So, larger magnet is definitely faster. So I just freshly emptied the collection bucket, and now I'm going to do an experiment. I'm going to run this bucket of material through. I'm going to put it back down there. I'm going to capture all the tailings, and then I'm going to run it again once it's done and compare the amounts of iron that I collect. So there's our tailings collected. I'm going to switch out these buckets, just like so. Now I'm going to run this again. As you'd expect, running the material twice, I'm getting much less iron coming off. You see, we've got the majority of it done, but there's only a little bit of iron here. And I suspect a lot of that is coming from right here. See how there's an indentation? The magnetite is being eroded by the material that's falling down, and it's not being replenished. And so this has fallen off into here. I don't think it actually came from the tailings. So here we are, it stopped flowing. You can see that dent it's made. So here's the material that didn't get caught, and here's the material that came from the first pass. Yeah, so you can see the vast majority of it gets caught in the first pass. And I suspect this that's right here would just about exactly fit into this divot. Yep. I lose basically none. You can really tell by just how little is picked up when I run the magnet over the tailings pile. See that? Very little. This is what it looks like when I'm running the material for a second time to purify it further. See, it's pouring out just the same as it was. It's just got a greater portion of the magnetite. So you can see there's the dirt that made it through the first pass. But you'll see I've got the bucket pushed forward here so that I'm only capturing the magnetite. So the stuff over here is very pure. And as a result, I'm losing a bunch of magnetite over here, but I am capturing it in this bucket so I can just put it back into the system. So here's the material after being run through twice. You can see it's a little dusty, but it's almost pure magnetite now. Like it's better than 90%. And here's the material that came off during the second run. It's maybe about 30% magnetite. I'm not going to discard it. I'm just going to put it through and run this again as if it was a first run stuff. I'll let the small one take care of that. Back when I was trying to find a better method of separating the iron than just holding the magnet with my hand, I thought about just running a stream of sand past the magnet and use the magnetic field to pull the magnetic particles away, kind of deflect them into a bucket or something, much like you would blow the chaff out of a stream of grain, right? So here's what happens when I did that. So I got my stream of sand. You'll see some of the material is sticking to the magnet and the rest of it is being sprayed over a wide area. Now if I move this sand away from the magnet far enough that the material no longer sticks to the magnet, then hardly any of the material is actually deflected. It actually stays in the stream of sand. And again, if I get it close enough that the magnet is able to actually deflect a significant amount of it, it's sticking to the magnet. Eventually it builds up to the point that the stream of sand starts colliding with it, as you can see here. And now all of the iron particles are sticking to the magnet, but you'll notice the sand is still being deflected. It's bouncing off. It's landing over here. Eventually I realized that there's a maximum amount of iron that this magnet can hold, and once you reach that point, any more that you add kind of slides around and then drips off the bottom, as you can see it doing here. Now, there's several things that are really great about this. You see, the iron is being confined in a very small space. It's not being sprayed around. I don't have to worry about it sticking to the magnet because the magnet's already full. And we're getting good separation from the sand because the sand is basically falling off the edge over here, whereas the iron is falling off the very bottom. And so you got a shadow effect. It's protecting the iron from becoming contaminated. So I'm able to get very good separation. You can see there's a pretty good gap right here between the iron and the sand. So this works really well and is super simple. That's a good combination. So here we are. After about a day and a half of work, I managed to fill 2 of these 17-gallon containers with the magnetite sand. You can see it weighs about 20 pounds per gallon. So you're looking at about 800 pounds of magnetite here. And this is pure enough that I can use directly for making thermite. In fact, this is the material I used when I was making my cast iron pan from the thermite reaction. I think that's pretty good. There's like potentially half a ton of thermite right here. So now you know how I've been mining my magnetite. Hope you enjoyed, and I'll see you next time.